Welcome everyone to AI Mavericks, the podcast where we dissect the cutting edge of artificial intelligence for business and technology leaders. I'm your host, and today we're tackling a really fascinating challenge. How do we know if AI is making good judgments, especially when the tasks get incredibly complex? And even more intriguingly, can we use AI to judge AI? We've got a fantastic panel of experts with us today to unravel this. Let's jump right in. Expert 1, maybe you could set the scene. Why is evaluating LLM responses such a critical bottleneck right now?
Absolutely, thanks for having me. Well, LLMs are everywhere, right? From drafting emails to complex legal analysis, even medical diagnostics. But ensuring the correctness of their output is paramount. Mistakes aren't just typos anymore, they can have serious real world consequences.
And the traditional methods just aren't scaling. Human evaluation is often seen as the gold standard, but it's slow, incredibly expensive, and let's be honest, prone to human biases and inconsistencies. Plus, some of these tasks are becoming so specialized, finding enough qualified human evaluators is a challenge in itself.
From a business perspective, that's a major roadblock. We want to deploy these powerful tools, but the cost and time lag for quality assurance can kill the ROI. We need faster, more reliable feedback loops, especially in high-stakes environments like finance or healthcare. It's like wanting to race a Formula One car, but only having bicycle mechanics to check it over.
So the idea emerged to use LLMs themselves as evaluators, often called LLM-as-a-judge. Expert 4, how well has that approach worked so far?
It's shown promise, definitely. LLMs can process vast amounts of information quickly and apply evaluation criteria consistently, often much faster than humans. Think of it like an automated spell checker, but for intricate reasoning and factual accuracy. Initial studies, like the one by Zhang and colleagues mentioned in the background paper, showed strong LLMs could align reasonably well with human preferences on open-ended questions.
And it's a big, but it's not a silver bullet. We've seen issues. Positional bias, where the model prefers the first answer it sees. Verbosity bias, favoring longer answers. Self-enhancement bias, where a model might subtly favor responses similar to its own style. And crucially, their reasoning isn't always transparent or sound.
Exactly, and the real kicker, which this new research highlights, is that most efforts focused on aligning LLM judges with human preferences. But what if the humans are wrong? Or what if the task complexity exceeds typical human capability?
That's a profound point. We're assuming human judgment is the infallible benchmark, but for really complex, specialized domains that might not hold true. Expert 6, does this resonate with you?
It absolutely does. In fact, I'd argue we've been overly reliant on the human benchmark. For tasks involving deep factual recall across obscure domains or intricate logical chains, top-tier LLMs might already outperform the average human evaluator. So optimizing for human alignment could actually be optimizing for a lower standard in some cases. It's a bit like asking a world chess champion to evaluate their moves based on what a casual club player thinks.
Okay, so if we can't always rely on humans and single LLM judges have their own flaws, how do we evaluate the judges themselves? This brings us to the core idea of the paper, LLM as a meta-judge. Expert 2, can you walk us through this proposed framework?
Sure, the researchers propose a really structured three-stage pipeline to tackle this. It's designed to select high-quality judgments from a potentially noisy set generated by an initial LLM judge. Stage 1 is all about the foundation, prompt design and rubric development. They didn't just write a simple prompt. They started with human experts defining a basic rubric, then used GPT-4 to flesh it out into detailed descriptions for multiple criteria, things like accuracy, logical soundness, completeness, fairness, relevance, clarity, impactfulness. GPT-4 even helped assign weights to these criteria.
So, really crafting a detailed scoring guide, almost like for Olympic judges.
Precisely, a comprehensive, multifaceted scorecard. This detailed rubric then forms part of the prompt given to the meta judges. It ensures everyone is evaluating against the same rigorous standards.
Then comes stage 2, which I find particularly innovative, the multi-agent meta-judge module. Instead of relying on just one LLM to assess the initial judgment, they use a panel, typically 3 advanced LLMs.
Why multiple meta-judges? What's the advantage?
It's about robustness and reducing individual model bias. As the saying goes, 2 heads are better than 1, or in this case, maybe 3 LLMs are better than 1. Each agent scores the original judgment based on that detailed rubric. Their scores are then aggregated. It's a way to leverage diverse perspectives, even within AI, to get a more reliable consensus.
And they explored different ways to aggregate those scores. Weighted averaging, where each agent's score contributes based on a predefined weight, maybe giving more weight to a model known to be good at logical reasoning, for instance. Majority voting, which is simpler, if more than half the agents score above a threshold, the judgment passes. And panel discussion, where agents actually share their reasoning and potentially influence each other before a final score is derived.
Okay, that sounds computationally more intensive. The panel discussion part.
Oh, definitely. The paper notes the cost implications. Independent scoring is cheaper. Panel discussions where agents iteratively refine based on others' input can double the cost or more, especially if you add a dedicated summarizer agent.
And the final step, expert 4.
Stage 3 is selection based on the aggregated meta-judge score. You set a threshold. The paper used 4.5 out of 5, for example. Judgments scoring above this threshold are deemed reliable and selected. Those below are filtered out. It's a quality control mechanism, essentially separating the high-confidence judgments from the questionable ones.
So the pipeline is detailed rubric, multi-agent scoring, threshold filtering. How well did it work in practice? What did the experiments show?
The results were quite impressive, actually. They tested this on the JudgeBench dataset, which is designed to be challenging, using judgments generated by GPT-4o Mini initially. The raw judgments from this judge had a precision of around 61.7%. Applying the baseline meta-judging method, a single LLM assessing its own judgment with a simple rubric bumped this up to about 68.9%.
But their full multi-agent pipeline pushed precision significantly higher. Depending on the task and the specific multi-agent strategy, they saw overall precision jump to around 75–77%. That's roughly a 15.5% improvement over the raw judgments and an 8.4% boost over the single-agent baseline meta-judge.
From a business standpoint, a 15% jump in the reliability of AI judgment evaluation, that's huge. That translates directly to lower risk, higher quality outputs, and potentially faster deployment of AI systems in critical functions. It moves the needle from interesting experiment towards dependable business process.
Were there nuances in how well it worked for different types of tasks?
Yes, definitely. The paper breaks it down for knowledge, reasoning, math, and coding tasks. For instance, they found that for knowledge tasks, using the same model for both judging and meta-judging actually worked quite well, likely due to internal knowledge overlap aiding self-reflection. That was using the simple baseline rubric.
But for complex reasoning tasks, more powerful meta-judge models and longer, more detailed rubrics tended to improve precision. Math tasks also benefited from comprehensive rubrics. Coding, interestingly, seemed to do better with simpler rubrics, perhaps because criteria like fairness or contextual relevance are less applicable there. Trying to apply an overly complex rubric can actually hurt performance sometimes. It's not one size fits all.
And building on Expert 4's point about model capability, they showed that if your initial LLM judge is a less capable model, say Llama 318B, using a stronger model like GPT-4o as the meta-judge provided a significant boost, around 16% improvement in precision compared to just having the weaker model evaluate itself. So, you can potentially uplift the quality assessment, even if the primary judge isn't top of the line.
That's a practical insight for teams with mixed resources. Now about those multi-agent strategies, weighted average, majority vote, panel discussion. Any clear winner?
It was task-dependent again. Majority voting really shone for knowledge and coding tasks, giving the biggest precision gains there. Weighted averaging seemed best for reasoning tasks. Panel discussion, surprisingly, performed best on math tasks but didn't dominate overall like some might expect from other multi-agent research in dialogue systems.
Why do you think the panel discussion wasn't the clear winner across the board? Any theories? Expert 1, you looked intrigued.
Well, the authors speculate, and I tend to agree, that for these very challenging judgment tasks, forcing convergence through discussion might actually be detrimental. You might lose valuable diverse opinions or signals from the individual agents. Sometimes, independent assessment followed by aggregation, like voting or averaging, preserves that diversity better.
It could also be information overload, especially if you add summarizer agents. The agent has to track the question, the two answers, the initial judgment, and the meta judgments from its peers. Maybe it just gets too noisy.
Or perhaps the roles assigned in some panel discussion experiments, like expert, critic, public, weren't distinct enough for this specific meta-judging task, leading to ambiguity or cognitive errors compounding. It's an area ripe for more research.
That's a good segue. Expert 6, hearing all this, what challenges or alternative perspectives come to mind? Are we potentially just kicking the can down the road? Who judges the meta-judges?
That's the perennial question, isn't it? The quis custodiet ipsos custodes. Who watches the watchers? While this framework improves robustness, it doesn't eliminate bias entirely. The meta-judges themselves are LLMs trained on vast datasets, potentially inheriting subtle biases. The rubric, even refined by GPT-4, ultimately stems from human input and values. And I'd also question the overwhelming focus on precision as the primary metric in the paper. Precision tells you, of the judgments we selected as good, how many actually were good. That's important for reliability. But what about recall? How many truly good judgments did we miss or filter out because they fell just below the threshold? In some applications, maximizing the capture of good judgments might be as critical as ensuring the purity of the selected set.
That's a fair point, Expert 6. From a business risk perspective, high precision is often paramount. You want to be very sure about the judgments you do trust. But for discovery or exploration tasks, maybe higher recall is more valuable. It likely depends on the application's tolerance for false negatives versus false positives.
I agree with Expert 3 on the application context being key. And building on what Expert 6 said about bias, we need ongoing monitoring and potentially adversarial testing, even for the meta-judge layer. How does the framework perform on judgments designed to fool it? Does it exhibit its own forms of bias? We need processes for that continuous validation.
So the framework represents a significant step forward, but it's not the final destination. Let's talk about that future. Expert 4, the paper mentions using these meta-judge scores for reinforcement learning from AI feedback, RLAIF. Can you unpack that?
Right. This is potentially one of the most exciting implications. Instead of relying solely on human feedback to train LLMs to be better judges, which is expensive and has the limitations we discussed, we could use the high-confidence judgments selected by this meta-judge pipeline as training data. Essentially, the meta-judge scores act as a proxy for quality. You can use these scores to create preference datasets automatically. This judgment was good, high score. That one was bad, low score. Then you can use techniques like direct preference optimization, DPO, to fine-tune the original LLM judge model to produce better judgments more often. It creates a potential path towards self-improving evaluation systems with much less human supervision.
It's like creating an automated quality control loop that not only filters current judgments, but also teaches the original judge to get better over time. This could dramatically accelerate the improvement of LLM evaluation capabilities, especially for those complex superhuman-level tasks.
The business implications of that are profound. Imagine AI systems that not only perform tasks but continuously refine their own quality assessment capabilities, becoming more reliable and trustworthy autonomously. This addresses scalability and cost, but more importantly, it builds a foundation for deploying AI in increasingly complex and critical roles with greater confidence. It reminds me of Deming's cycle: plan, do, check, act, but applied to AI judgment itself.
Are there any real-world scenarios where this kind of robust, potentially self-improving AI judgment evaluation could be a game-changer right now? Expert 5, perhaps.
Absolutely. Think about automated content moderation at scale. Evaluating nuanced cases of hate speech or misinformation is incredibly challenging for humans and current systems. A robust meta-judgment framework could improve the consistency and accuracy of moderation bots. Or in legal tech, evaluating the relevance and quality of AI-generated case summaries or discovery documents. The stakes are high, and human review is costly. Another area is scientific research, evaluating hypotheses generated by AI or the quality of AI synthesized research papers. As AI pushes into more complex domains, our ability to evaluate its outputs reliably becomes the limiting factor. This framework helps address that. We recently worked with a financial services company exploring LLMs for compliance checking on marketing materials, ensuring claims were accurate and adhered to regulations.
Fascinating examples. It sounds like this meta-judging concept, especially the multi-agent approach, offers a powerful new tool in the AI quality toolkit. Any final thoughts or key takeaways for our audience of leaders? Expert 1.
For the tech leaders, don't underestimate the complexity of evaluation. Simple benchmarks aren't enough. This multi-agent meta-judge approach offers a path to more nuanced, reliable assessment, especially as you push LLMs into harder problems. Experiment with different strategies, averaging, voting, see what works for your specific tasks.
And pay attention to the rubric. Garbage in, garbage out applies here too. Collaborating with domain experts, and perhaps even using LLMs like GPT-4 to help refine the rubric, is crucial for getting meaningful meta-judgment scores. Don't just slap a simple "is this good" prompt on it.
For business leaders, reliable AI evaluation isn't just a technical detail, it's a strategic imperative. It impacts risk, ROI, compliance, and ultimately trust. Investing in robust evaluation frameworks like this isn't overhead. It's an enabler for leveraging AI effectively and safely in high-value applications. Ask your tech teams how they're ensuring judgment quality.
Look towards the future. The potential for RLAIF and self-improving systems is real. This isn't just about filtering judgments today. It's about building more capable and trustworthy AI judges for tomorrow. Keep an eye on developments in unsupervised and semi-supervised alignment techniques.
Be practical. Start small, perhaps validating the meta-judge approach on a specific, challenging use case. Understand the costs and complexities, especially of multi-agent systems, but recognize the potential payoff in terms of scale and reliability compared to purely manual evaluation.
And maintain healthy skepticism. Remember the limitations, potential for inherited bias, the precision recall trade-off. Meta-judges are a powerful tool, not magic. Continuous monitoring, diverse testing, and acknowledging the context of the application remain essential. As Feynman said, the first principle is that you must not fool yourself, and you are the easiest person to fool. Let's apply that to our AI systems too.
Fantastic insights from everyone. We've gone from the challenges of evaluating LLMs through the intricacies of LLM-as-a-judge and into this really innovative multi-agent meta-judge framework. It's clear that as AI capabilities grow, our methods for ensuring their reliability must evolve too. This approach seems like a significant step in that direction, balancing technical rigor with practical application. Thank you, Expert 1, Expert 2, Expert 3, Expert 4, Expert 5, and Expert 6 for a truly enlightening discussion. And thank you to our listeners for tuning into AI Mavericks. Join us next time as we continue to explore the frontiers of artificial intelligence. Evaluating responses from large language models is increasingly complex. Using large language models for evaluation is faster than human evaluators. However, human judgment can have biases and mistakes. Current methods often overlook these issues in human evaluation. This paper proposes using large language models as meta-judges. A meta-judge is a language model that evaluates the quality of another language model's judgment. The goal is to accurately select high-quality judgment made by language models. The researchers developed a three-stage process. First, they created a detailed evaluation guide using GPT-4 and human experts. This guide or rubric has criteria like accuracy and logical soundness. Second, multiple advanced language models act as agents to score judgments using the rubric. These agents collaborate using strategies like weighted averaging or majority voting. Third, a score threshold filters out low-scoring, unreliable judgments. This multi-agent meta-judge framework improves judgment selection. Experiments use the JudgeBench dataset for evaluation. The proposed method improved precision by about 15% compared to raw judgments. It also improved precision by over 8% compared to using a single meta-judge model. Different tasks like reasoning or coding may benefit from different rubric details or agent strategies. Using a more capable model as a meta-judge helps when the original judge model is weaker. A noted limitation is the relatively small dataset used for experiments. This work shows language models can evaluate judgments without direct human oversight. The meta-judge scores could help build datasets to train better language model judges. This research supports developing automated and scalable evaluation systems.